Welcome back to our semi-final class for week module number 5. Our topic is all about delta and Y circuit connections. We learned in a previous page that resistors can be connected in series or in a parallel. Sometimes circuit analysis is easier if we convert series or parallel resistor into a single equivalent resistor. However, resistors can be configured in a way that does not result in a series connection or a parallel connection. So giingon dere nga sa ato ang last topic, di ba, naghisgot na ta about series or parallel circuit. So to make it easier di ay dapat if na ay series or parallel, so need nato siya i-convert into a single equivalent resistor para mas madali ra nato ma-solve. It is possible to convert a delta network into a functionally equivalent Y network, and it is also possible to convert a Y network into a functionally equivalent delta network. So functionally equivalent means that the overall electrical behavior of the converted network is identical to the overall electrical behavior of the original network. In other words, if the original network is connected to the system at terminals A, B, and C, so we can remove the original network and connect the converted network to terminals A, B, and C without changing the behavior of the system. So giingon diri nga pwede ta maka-convert if example we have our delta network into Y or vice versa. So at this point, we know what a delta Y conversion is. But we don't know why someone would want to perform these conversions. It turns out that converting a delta network to a Y network or Y to a delta network can facilitate the analysis of a larger circuit that includes a delta or Y network. In the next section, we'll look at the conversion formulas. Then we'll work through an example. So we have here our figure. So delta converted to an equivalent Y connection. So mao ni siya ang delta and Y network. So makita nato sa ato ang delta. So mura siya triangle, no, since delta good. And for the Y, so Y network, it is same ang iyang figure is Y ang iyang figure. So sa ato ang delta, we have RAB, so from A to B, and we have RAC from A to C, and we have RBC, so gikan siya sa B to C for the delta network. In our Y network, we have RA from A to the center, and we have RB, so B, and we have RC. So in a delta Y conversion formulas we have here, so the following formulas allow you to calculate Y network resistance from delta network resistance. So kaning formula nato gikan siya sa delta to Y network. So for solving for RA, so from delta nato we have RAB multiply to RAC divided by sum of the three resistors. So we have RAB plus RAC and RBC. So same in RB, ang denominator same ra sa RA ganina, ang nalahi lang kay naa siya ang atong numerator is RAB multiplied by RBC. So same in RC, RAC multiplied to RBC divided by the sum of the three resistors. So mao ni siya ang formula to convert from gikan sa delta network to Y network. So we have also a formula to calculate delta network resistances from Y network. So gikan sa Y to delta network. So we have here our formula. So RAB is equal to RA multiplied to RB plus RA multiplied to RC plus RB multiplied to RC over RC. So sa RAB na, take note. So for RBC, so same ra ang taas, ang lahi, RA. And RAC, we have same ra pod and over RV. So take note, if resistances are equal, so if equal ilang given sa tong resistance sa delta or Y network, so our formula will be R delta is equal to multiply by 3 multiply sa ato ang RY. So magamit ra ni siya if equal ang given sa ato ang formula. So let's have our example for delta Y conversion. So for example number 1, 3 resistors of 35 ohms, 25 ohms, and 40 ohms are connected in delta. What are the resistances of an equivalent Y connection? So we have here, so naghatag siya tulo ka 3 resistor sa connected daw in delta. So first we need to draw our figure. So we have 35, 25, and 40 ohms. And we need to convert it in Y connection. So we have our R1, R2, and R3. So solving for R1, so formula na to sa taas, we have 35 multiply to 40 over ang tulo ka resistor, total niya is 100. So the R1 is 14 ohms. So try na to in our calcu. We have 35 multiply by 40 divide the total resistance which is 100. Try na to. 35 plus 25 plus 40. So the R1 is 14 ohms. So same sa R2. Ang sa R2, ang nabago niya is 25. So our R2 is 8.75. Wait. 8.75 ohms. And for our R3, so 25 multiply by 40 over 100. So our R3 is 10 ohms. So very easy lang, no? Since formula man siya tanan. So we have our final answer here. For R1, 14 ohms. R2, 8.75 ohms. And R3 is 10 ohms. So proceed for our example number 2. So we have here 6 equal resistor, each of 3 ohms, are connected to form a Y inside a delta. Calculate the distance between any two terminals of the delta. So giingon na siya 6 equal resistors. So diba sa note na to ganina nga if 3 equal resistors, so we need to multiply lang R delta is equal to 3 RY, which is ang atong given nga resistor is 3 ohms. So therefore, our answer is 9 ohms. So to convert first the Y connected resistor to its equivalent delta so that the circuit will become two delta connected resistors connected in parallel. So giingon dire, so nanatay answer 3 ohms and 9 ohms. So, ang giingon man sa problem, diba, distance between any two terminals of the delta. So, wala tay. So, to solve for the parallel, R parallel niya, Since natay given nga na-solve na to nga 3 ohms and natay 9 ohms. So ang parallel ana is equal to 9/4 ohms. So we have here, so duha 9. So to final circuit is parallel of 9/4 and 4.5 ohms. So parallel ra na siya. Kani di ba? Parallel ang atuang 9/4. So ang answer ana is 4.5 since 4.5 is also parallel sa atuang 9/4. So to solve that, our final answer will be 1 over na-solve na to nga 9/4 plus parallel nga 4.5 ohms. So our answer will be 1.5 ohms. So mo ni siya ang atuang distance from RAB. Take note na, no? 1.5 ohms. So proceed na for our topic for our module number 5 for semifinal. So we have also a cubical connected identical resistors. So you have probably seen somewhere along the line in your electronics career the resistor cube problem. So the 12 edges of the cube each contain a 1 resistor, and the challenge is to calculate what the equivalent resistance is between two opposing corners. It is a problem using straight circuit analysis. So kaning cubical, we have to solve. So inani na figure. So to solve this, we need to use the traditional method. So traditional method use involves recognizing sets of equipotential points within the vertices of the cube, then shorting them together to enable calculation of parallel resistances. So makita na to, we have our cube structure consisting of 12 resistors electrically connected between the 8 vertices. Each resistor is 1 ohm. But any value can be used so long as they are all the same. So pwede ta mo gamit bisag unsa na values at as long as same ang ilahang given nga value. So for our example, our value is 1 ohm. To simplify that, so mo ni siya, here is the intuition comes into play. So we have here our, so mao ni siya color coding gilahi and na-labeled para matrack na to ang resistor nga associated sa nodes niya. Ang nodes kaning dere, kaning na mga point. So once you short those nodes, you obtain the equivalent circuit shown below. So kaning dire sa taas nato sa tuang cube, so kaning ABC, we have kaning tulo parallel ni siya, where parallel answer is A is parallel to B and C. So our answer will be, if resistor na to is 1 ohm, is 1/3 ohms. So kaning ABC here, A, B, and C diri sa ubos. And kaning D, E, F, G, H, I, so makita na to atong D, E, F, here kaning F sa taas, G, H, and I is also a parallel. So ang answer niya is 1/6 ohms. And our lain na to na node kaning J, K, N, we have our L. So the answer same atong una, 1/3/3 3. So, after nato, masolve ang ilang parallel. So, the answer is all in circuit. So, circuit. So, add series circuit. So, in series, so total resistor. So, we need to add lang all the answer. So, we have 1/3 plus 1 over 6 plus 1/3. So, our answer is 5 over 6 ohm. So, mao na siya ang atoang answer sa cubical. So, try na to sa ato ang example. So, we have here 12 identical wires of resistance 6 ohms. Each are arranged to form the edge of a cube. A current of 50 milliampere is fed into the cube of one corner and out of the other diagonally opposite corner. Calculate the power developed between these corners. First, sa cube na to, so naghatag siya 6 ohms ang atoang resistor sa aning cube. And I total which is 50 milliampere. To solve first the equivalent resistors of the main diagonal of the cube. So, di ba ang natong na-solve ganina is 5 over 6 ohms. Since natay R nga given which is 6 ohms. So, we need lang to substitute. We have here 5 over 6. Which is constant na siya, and our R, we have 6 ohms. So, our total is 5 ohms. Since ang unknown na to is the calculate the power developed between these corners. So, to solve for our total voltage, we have our formula from our last topic. I total is multiply to R total. So, 50 milliampere, negative 3 since milli, multiply sa 5 ohms na total resistor. So, our total voltage will be 0.25 volts. So, we have here our final answer. So, that's all for our topic in our module number 5 for semifinal. So, if you have any question, you can comment sa atong Google Classroom so that I will answer your concern. So, if you have any clarification, just comment lang sa atong Google Classroom. So, that's all for our topic this class.